Alright guys, so we're going to do a couple more examples for today's notes dealing with simplifying rational exponents. We just looked at one where as far as negative powers, changing it to from decimals to fractions, so on and so forth. Now we're going to move on to, we have two more examples here. Let's go to, so in your notes guys, please put this under your notes, example number 2. 3, 13, and 21 is really what we're doing, by the way. Okay, so let's look at number 13. We are looking at 2x to the negative 7/4 over 4x to the 4/3. Yeah, so this is like note/homework, okay? So I would like for you to put it in your notes, and you can just take a picture, transpose it to your homework when you do it. But basically, we're trying to get some good practice from the homework so you understand how to do it. Alright, so looking at this, I'm just curious, what would y'all want to do first? Say again? Rationalize the denominator. Okay, I see where you're going with this. Here's what I'll say. Let's not rationalize the denominator yet. Let's more so look at, I have two bases that are the same that are being divided. So what am I going to do with those powers? I'm going to simplify by subtracting those powers, right? So here we go. X to the negative 7/4 times, going to be divided by x to the 4/3 is simply going to become subtracting those like this. Okay? So if I'm subtracting fractions that don't have the same common denominator right now, I need to make sure that I multiply this by a form of 1 and this by a form of 1 so that I do now, and the reason why I chose 3 is because that's what this one had, to get 12. The reason why I chose 4 is because that's what this one had, to also get 12. Okay? You want to do this by hand, not with a calculator. So negative 21 over 12 is going to be minus 16 over 12. Go with me? Okay, so what do I get right there? Negative 37 over 12. So if I have x to the negative 37 over 12, ultimately, where is this going to happen? Where is it going to belong as a positive? In the denominator. Because right now, my answer is like this over 1. Okay? So I'm going to end up having this as an answer in the denominator with a 37/12 that looks just like that. Yeah, I'm not there yet. The 2 and the 4 will reduce to 1/2. So you have 2x to the 37 over 12 in the denominator and a 1 in the numerator. Okay? Now, here comes the question. This is square rooted right now. It is. Or not square rooted. It's in complex form, like a radical is underneath, is in the denominator right now. So if I wanted to rationalize the denominator, don't put this in your notes, but watch. I would raise this to the 12 over 37. I would raise this to the 12 over 37. Whoops. Because a power raised to a power, that means you're going to be multiplying these things. What number would these become when I multiply? It'd be a 1. And now I've just rationalized the denominator. I don't have a square root in the denominator. But I would have to apply it to that one too. Do you see how I still now have a square root in the denominator, no matter what? So on instances like this, I wouldn't want you to raise it to the 12 over 37. You know what I mean? This is not like the conjugate where you got rid of all square roots. And this is not like multiplying by a square root where nothing is left square root wise in the denominator. Okay, these are rare, and if you have something like this, I would only expect you to write that and be done with it. So 1 over 2x to the 37 over 12 is good enough for me. Questions?
It's not a negative.
It's not a negative because over here, it was a negative in the numerator. We're taking that that negative out of the world, so we would move it across that division symbol by making it a positive in the denominator. Again, if it's negative downstairs, bring it upstairs as a positive. If it's a negative upstairs, take it downstairs as a negative. Alright, so let's look at number 21. So we have x to the negative 1/2 times y squared to the negative 5/4, and it's all over x squared y to the 1/2. Again, looking at it like PEMDAS, I'm going to kind of look inside of these parentheses and see, is there anything that I could simplify? Okay. Can I add these two together, guys, right now, since I'm multiplying? No, I cannot. Why not? They're not the same base. I can only do that if they have the same base. Okay? So they don't have the same base. So then with PEMDAS, I'm going to move on to the exponent. Now there's two things that you could do with this. You could take this whole thing and move it downstairs as a positive 5/4. You'll see that? Or, which I would probably do, is just break it up to each individual piece first. Yeah, so like this 5/2, negative 5/4 is going to multiply with negative 1/2. There's a power raised to a power, you multiply, and what would I get? I'd get x to the what? 5/8. Now, I'm going to apply it to this one as well. Power raised to a power, we're going to multiply. Okay? And I hope you're doing it this way. What's an understood one here? I would hope that you would reduce this to 1 and 2, and then multiply and see what do you have on top and what do you have on bottom. Guys, what would I have? Negative 5/2. So, negative 5/2. And then downstairs we still have x squared, and downstairs we have y to the 1/2. Okay, you ready? I see negative powers. That's the first thing I want to do is take the negative out of the world. So y will go downstairs to join this 1/2. I'm doing it in as many steps as I can so that you can follow and not get confused. And later go and watch the video if you need to. Can I combine my y's? Yes. Multiply or add? I will add. Okay? So 1/2 plus 5/2 would give me 3. So I have y cubed in the denominator. It's positive, so it's good to go. See, when you see these things like x to the 5th over x squared, they're easy because you just have 5 on top, 2 on the bottom. The top wins, so you would reduce to x to the 3rd. But when you have these weird fractions, you got to use the rule of same base, dividing. What do I do? What do I do with the powers when I have the same base and I'm dividing? Subtract. So 5/8 minus 2 is the same as, multiplied by a form of 1, 16/8. Right? And what would I get there? Negative 11/8, right? So negative 11/8, it's x to the power of negative 11/8. You tell me, does that belong in the numerator or denominator? In the denominator. And when I move it, I will make it positive. 1 is understood. There's your answer. Ask me questions if you have them. Yes. So right now, when I did, and that's what I was saying, guys. Whenever it's easy like this x to the 5th over x squared. Come on, computer. Visually, it's easy to see that the top will win by 3. But now look, if I set this up as x to the 5 minus 2, I'm left with a positive 3. This positive says it belongs in the numerator, which is what it had, like over 1. when I do this subtraction with these weird numbers, and I get a negative power, this tells me it belongs in the denominator because it was negative the way I set it up, right? And then I would make it a positive once I moved it to the denominator. Okay, does that make sense? Okay. All right, kind of scan your homework. I'd like to do one more if possible. Scan your homework real quick. Try to find one that you think is really, really difficult. And let's do that before we finish for today.
What about 22?
22, okay. So 22, let's look at 22. X to the negative 1/2, y to the 4th is raised to the 1/4. And then we have x to the 2/3, y to the 3/2, x to the negative 3/2, and y to the 1/2. Okay. What should we do with this 1/4?
Split it
Yep, apply it into both. I know it looks and feels like distribution, but we're not distributing, we're applying it. And what am I going to do with negative 1/2 and 1/4 right now? I'm going to multiply them. And what do I get? Negative 1/8. How about 4 and 1/4? I get 1. Okay, and I'm just going to leave it like that. I'm not going to write there a 1. It's just understood as 1. Can I group these x's on the bottom together because I'm multiplying? Yes or no? Yes. Because I'm multiplying, what will I do with these things? I will add them. Okay? Up top, it was a power raised to a power, and that looks like this. Here, we multiply. Power raised to a power, you multiply. But down here, when you're multiplying by bases, you are going to add those numbers. Here we go. Here's a shortcut to add fractions in case you don't already know this. So I'm going to add 2/3 with the negative 3/2. So that's the same as this. Yes, I could multiply this first one by 2/2 and the second one by 3/3, but I'm not going to do that. I'm going to do a shortcut that will get me there faster. 2 and 2 give me 4. 3 and 3 give me 9. I'm subtracting, and now I'm going to think to myself, what would these be if I multiplied to get a common denominator, and we would get 6. It's the same thing if you were to work it all out and see the first one was 4/6 and the next one was 9/6, and if you subtract it, you would get the same thing, just a little bit faster.
Wait, how are you getting 6?
Okay, the 6 is my original denominators multiplied together will give you that 6. That's that common denominator. So 4 minus 9 is a negative 5. So I have negative 5/6 is what this would be. Check this one out, Nishi. This one has a negative 5/6 as it was in the denominator. You understand? So ultimately, where are we going to move it? It's got to go to the numerator as a positive. Alright, so let's add some fractions. 3/2, 1/2 gives me 2. And now you see the only one that's going to move is this 5/6. It's going to move upstairs. And guys, if you have to do all of this little work, that's fine. You see, this 1/8 would end up moving downstairs. Okay? And then you'd have y and y to the second. Some of you were probably thinking of something different, and that's okay. Some of you might have been thinking, why don't I just take this and subtract that? And then 1 minus 2. To me, the way I like to see it is I like to get them as positive as possible and as fast as possible, and then do that math here. You with me? So here we go. 5/6 minus 1/8. Here's that trick again. 46. It is subtracting. And then the product of my two denominators is 48. So I'm left with what? 36 over 48. which will reduce to what?
3/4.
3/4, right? So it's a positive 3/4 the way I had it set up here. Oh, wait. It's 34. Okay, I'm sorry. Thank you. 34 over 48. What does that reduce to? 34 over 48. 17/24. Okay, here we go. Does that belong in the numerator or denominator the way I did it? In the numerator. Okay. And this one's easy to see because these are nice whole integers. 1 and 2. Top has 1, the bottom has 2. Who won? The bottom. By how much? 1. If you don't see it that way, then put 1 minus 2, because you're looking at the top minus the bottom, because it is division with the same base, and you would get y to the negative 1. Y to the negative 1 belongs where? In the denominator in this case, so you can move it down. So many ways to make a negative mistake. So many ways to add or subtract fractions. So if you were struggling with adding or subtracting fractions or multiplying and dividing fractions, we have to clean it up this unit for sure. Okay? This right here, this unit is why I've always pushed fractions, fractions, fractions. And we still have more coming of these kind of concepts. Okay? Questions? Alright guys, you can work on homework for the rest of the time.